Alright, so today we're going to start our work into section 8.3, and we're going to start with some special right triangles. Today's focus is going to be a special right triangle family called 45, 45, 90. That name references the angle size in the triangle. Alright, so we're going to start by taking a look at this square. Alright, it says draw a diagonal in the square, so I'm going to go ahead and do that for you. Let me get a pen color that you can see. Alright, and then it says redraw the triangle. Alright, that was created. So if I do that, I've got a right angle down here, a 4 on each of these sides. Alright, and asks me to find the length of that diagonal. So this looks like a Pythagorean theorem. I'm going to call this x. So 4 squared plus 4 squared equals x squared. 16 plus 16 equals x squared. 32 equals x squared. If I take the square root of both sides, I end up with 4 root 2 when I simplify that. Alright, so the diagonal of a square of length side, a diagonal for a square with a length of 4 for the side is 4 root 2. Alright, now what we're going to do is we're going to look at this in a very general situation. So we're going to repeat the same process. I'm going to draw on a diagonal. Alright, I'm going to come off here to the side. I'm going to draw that triangle. Alright, and again, we're still looking for x. So I'm going to do this with Pythagorean theorem again. So n squared plus n squared equals x squared. Combine like terms, 2n squared equals x squared. Alright, then take the square root of both sides. So square root of n squared is just n. It's the side of a triangle, so we don't need to worry about an absolute value. Alright, and you're left with a 2 inside the radical. So x equals n root 2. Alright, so what we could say in general is that if we have a square with side length n, then the diagonal will always be n root 2. We're going to look a little bit at these measurements. So one thing that we know is that if we have a square, we're going to have that these two angles are the same. That means each of them are 45. Now, if each of those are 45, each of these are 45. So we're really looking at a 45, 45, 90 triangle. All right, and that is our special case. So in a 45, 45, 90 triangle, all right, what's always going to happen is we're always going to have the leg and the leg are the same because it's isosceles. So opposite, those two legs have to be the same. And then by Pythagorean theorem, that last side, the hypotenuse, is always going to equal the leg times root 2. All right, now in a general sense, what we typically do to draw this is I remember it by just putting some variables. So n, and n root 2. All right, so we're going to use this picture a whole lot when we're dealing with a 45, 45, 90 triangle. Because the first thing we're typically going to do is we're going to drop those labels, the n, and the n root 2, on our picture. So let's jump to some where we're going to use this. All right, so I'm going to look at this first one. All right, so we've got a 45, 45, 90 triangle. So I'm going to go around the inside. I'm going to put my labels, n, and n root 2. All right, so right here, it's very clear that my n value equals 8 from here. All right, and the x value that I'm looking for is n root 2, but in this case, that's 8 root 2, because we already found out that our n value is 8. All right, and that's our setup for the first one. If I jump to the second, all right, I'm going to go the same route. So n, and n root 2. All right, so I look at the side that I know the piece of information on. So n root 2 equals 3 root 2. I'm going to solve for n, so divide both sides by root 2, and n equals 3. All right, we know that the x value we're curious about is the same as n, so that means x equals 3. All right, taking a look at the last one here on this top group, I'm going to go with my labels, so n, and n root 2. And again, I know these are 45 because it's an isosceles triangle, so it has to split that last 90 degrees evenly. All right, so I go to the side where I know both pieces, so n root 2 equals 18. I'm going to divide both sides by root 2, so n equals 18 over root 2. Now, we have to rationalize our denominator, so I'm going to multiply top and bottom by root 2. That gives me an 18 root 2 over root 4, which is 2. which reduces to 9 root 2. All right, and the n value is the x we're looking for, so x is 9 root 2. All right, so that takes you to the first three. All right, I'd like you to go ahead and try the next group on your own, the next 5 problems, and then jump back into the second video and you can check yourself. Thanks.